Hello dear students, today we are going to have a discussion on mock test series CUET in the subject of chemistry. This is brought to you by Toppscholars, the smart learning app. So let's begin.
First question we are having is a fill in the blank type of question. The question says the unit of V constant in case of zero order reaction is dash. Okay, so over here this V is standing for velocity. Basically, you are being asked about the velocity constant's unit in zero order reaction. Let us first have the options with us. We have option A which says concentration multiplied by time inverse. Then option B says concentration inverse into time inverse. Option C says concentration multiplied by time square. And last option D says concentration inverse multiplied by time. Now, if you remember this zero order reaction, then we can plot a graph wherein over here on y-axis we will have the rate and on the x-axis we will have the concentration of what? Of obviously reactant. Okay. Now, this graph will be having a straight line, meaning that the rate of zero order reaction is not dependent on the concentration of reactants. Okay, it is independent of the concentration of reactants. Now, we need to find out what is the unit of velocity constant. Hence, let us have a look over here. For zero order reaction, we will have velocity constant which is equal to dx by dt. Okay, this is the differential form. Now, this will be equal to concentration upon time. Over here, this concentration can be expressed in the terms of mole per liter. Okay, and this time can be expressed in the terms of second. Hence, the unit will be mole per liter and then we will have second inverse. Okay, or we can also write it as mole liter inverse second inverse. Okay, so this is the unit of velocity constant of zero order reactions. Over here, hence we can say that the unit is concentration multiplied by time inverse. Okay, don't get confused in this liter inverse because this whole term is the unit for concentration itself. Hence, over here this term is given in option A. Hence, we will have option A as the correct answer for this question. Now, let us proceed with the next question. The next question we are having is about hybridization. Okay, it is another very important topic with your exam perspective. The question says the hybridization, shape and magnetic property of this complex is what? Okay, the complex is Fe, into bracket we have H2O, then that is 6 times and the charge is of 2 plus. First of all, we will have the look on options. Very first option A is D2sp3 octahedral and paramagnetic. So, this one is the hybridization, octahedral is the shape and paramagnetic is the magnetic property. Then we have option B which says sp3d2 octahedral and then paramagnetic. Option C says sp3 square planar and then paramagnetic. Last option D says sp3d tetrahedral and diamagnetic. First of all, before going for your examination, you should be very clear on the terms. What is hybridization? How do you determine the shape? What is the magnetic property? What do you mean by paramagnetism? What is diamagnetism? Everything should be clear in your mind. Then only you can confidently attempt such questions. Over here, if you will see this Fe, H2O6 and 2 plus. This complex has Fe as the central atom, right? And this H2O is a weak ligand. Please remember that. Okay. Now, let us have the electronic configuration for this Fe, H2O6, 2 plus. First of all, we will have a look on the electronic configuration of iron itself. Fe is having atomic number of 26. Hence, the electronic configuration will be 1s2. Then we have 2, right? 2s2, 2p6. Now, then we will have 3s2, 3p6 and before filling 3d6, we will fill 4s2. This is as per Aufbau's principle, which you must be very familiar with, right? Now, if I want to have this 2 plus, then I need to lose 2 electrons and these 2 electrons will not be lost by this d6 but they will be lost by this 4s2. Okay, hence if we will see the electronic configuration of Fe2+, you can have a look that we are having 1s2, 2s2, 2p6, 3s2, 3p6 and then this 3d6. So we are not having 4s2. That means we have lost the 2 electrons present in 4s orbital. Okay. Now coming over here, the complex is consisting of 6 water ligands, correct? Hence the geometry is octahedral. Right? Now, this water is a weak ligand and hence the pairing will not take place in this complex. Okay? Hence, the inner orbitals are occupied by the electrons of iron itself. Hence, the hybridization is sp3d2. Now, since the electrons are not paired, we will have unpaired electrons and hence the magnetic property will be paramagnetic. Okay, so to sum up our discussion, we have came to the conclusion that hybridization is sp3d2, then we have shape which is octahedral and lastly we have magnetic property that is paramagnetic. This is due to the presence of 4 unpaired electrons. Okay, hence the correct answer will be option B for this question. Now friends, let us move on to another question. The next question we are having is asking us which of the following statement is true. So, let us have a look on the options. We have option A which says 2 different solutions of sucrose, okay, of same molality. You should know what is the meaning of molality, what is the formula of this molality. Is prepared in different solvents and then they will have the same depression in freezing point, okay. So, we need to see if this statement is true or it is false. Let us go for option B. It says the osmotic pressure of a solution is given by the equation pi is equal to CRT. Herein, C is the molarity of the solution. What is R and what is T? You might be familiar with, right? It is very simple thing. Then we have option C which says decreasing order of osmotic pressure for 0.01 molar aqueous solution of barium chloride, potassium chloride, acetic acid and sucrose is in this order. Okay. So, you need to check if the given order is correct or not. Okay. Lastly, we have option D which says according to this law, that is Raoult's law, the vapor pressure exerted by a volatile component of a solution is directly proportional to its mole fraction of solvent. Please students, in this type of questions, you need to take care of each and every word because of single word, the whole statement can go wrong. Let us have the analysis for this question. First of all, in option A, since we are having different solutions, that means you are having different solvent also, right? Hence, there would be no same depression in freezing point, okay? There will be different values of this depression in freezing point. Over here, this statement, kindly have a look, maybe this statement is correct. Over here, the sequence given to you is incorrect. See if you can find out what is the correct sequence. And lastly, for here, we have mole fraction of solvent. Here, solution should be there. Let us have a look. So, the value of depression in freezing point depends upon the nature of solvent. And since you are changing the solvent, that means the value will also change. Okay. This depression in freezing point is basically a colligative property. You should know what are colligative properties. Okay. Then we have second statement. It has been found experimentally that osmotic pressure is proportional to the molarity. Okay. And that is at a given temperature which is represented by T. Hence, we will have the formula pi is equal to CRT. Over here, pi is representing the osmotic pressure. Okay. Then over here, the order depends on the ease of solute or ions to pass through the semi-permeable membrane. Okay. Now, since if the solute particle is very big, then it will have difficulty in passing. And if the molecule is small, then it will pass very easily. Okay. Hence, the sequence will be BaCl2, KCl, CH3COOH and then sucrose. Sucrose is a large molecule as compared to these. Hence, it will be coming towards the end. Okay. Now students, the fourth statement says according to Raoult's law, vapor pressure will be directly proportional to the volatile component's mole fraction in the solution. Okay. Hence, the correct answer will be this option B because only this one is correct. Now, let us proceed with the next question. The next question we are having is asking us about details of carbanion. Okay. So, the question says which of the following is or are correct statement or statements about carbanion. Let us have the statements. We have first option, which is A. It says carbanion is the intermediate of carbon containing negative charge. Okay. Then we have option B, which says it has 8 electrons in the valence shell. Then we have option C, which says carbanion and ammonia are isoelectronic species. What do you mean by isoelectronic species? That should be clear in your mind as well. And it is also said that both of these are having same structure. Lastly, we have option D, which says that all of the given statements are correct itself. Okay. So over here, if we talk about this carbanion, this is an intermediate of carbon containing negative charge. Now over here, if you will have a look, we are having this carbanion. Okay. This is a carbon. Then we have 3 bonds, and then there is a negative charge and a lone pair present on this carbon. This structure is referred to as carbanion. This structure is an intermediate of carbon containing negative charge, okay, and it has 8 electrons in its valence shell. That means the octet is complete, okay. Coming over here, carbanion and ammonia are isoelectronic species. How? Let us see. Over here, this geometry is trigonal pyramidal. Here you will see this is the carbanion. We will have the negative charge along with the lone pair. And in this ammonia also we are having the negative charge. Because of this, both of them are having the geometry of trigonal pyramidal. Okay. So they have the same structure and they are also isoelectronic species. Okay. So we can say that all the statements given to us are correct itself. Hence, we will choose option D as the correct answer for this question. Now students, let us proceed with the next question. The next question we are having is about this P block or D block or S block or F block elements. We are provided with the atomic number and we need to predict in which block will this element be placed. Okay. The question says to which block S, P, D or F does the element with atomic number 50 belong? Let us have the look on options, then we will go with the analysis. We have the very first option, which is S block, then we have P block, then we have C option, which is D block, and last option D, which is F block. Okay. Now over here, let us have the electronic configuration for this element having the atomic number 50. Over here we have 1s2. Okay, we will be starting from lower energies and then we will go on increasing. Okay. So here we have 2s2 and 2p6. Then we have the third orbital starting. Hence we have 3s2, 3p6 and then 3d10. Now we have 4s2, 4p6 and then 4d10. And finally we have 5s2 and 5p2. So the last subshell in which the electrons are getting filled is 5p, right? And please note there is p, okay? So this element is having the electrons getting filled in p orbital, hence the block will be p block. The last electron enters into the 5p orbital, hence it is a p block element, okay? Now you need to just remember how to write the electronic configuration following the Aufbau's principle. Then whatever atomic number is given to you in your examination, if such question comes, you can easily predict to which block the element will belong, okay? So the correct answer over here is option B, which is P block. Now friends, let us move on to the next question. The next question we are having is asking us about Fajan's rule. Okay, the question says, which of the following statement correctly explains the Fajan's rule? Over here, we have the first statement which says, the smaller the size of the cation and larger the size of the anion, the greater is the covalent character of the ionic bond. Okay. Then we have B statement which says the larger the size of cation, it is just the opposite, okay? And the smaller the size of the anion, the greater is the covalent character of an ionic bond. Statement C says the greater the charge on the cation and the greater the covalent character will be of the ionic bond, okay? Last D statement says that the lesser the charge on the cation, the greater the covalent character of the ionic bond, okay? We need to find out which of the statements is actually correct as per the Fajan's rule. Let us have a look on options. We have option A, which is saying that A and B, both the statements are correct. Then we have option B, which says A and C are correct. Then we have option C and D. C says that A and D are correct and option D says that B and C are correct. Now, this Fajan's rule actually predicts whether a chemical bond will be ionic or it will be covalent. Okay, and we also have 3 postulates for this Fajan's rule, in which the first 2 postulates are given to you in your question. Over here, this first statement says that the cation should be smaller and the anion should be larger, and then the covalent character of the ionic bond will be the greatest. This statement is correct. Okay, this statement is incorrect and it is also opposite, so you can make a educated guess of which statement could be true if you have the detail about this Fajan's rule. Then here we have the greater the charge on the cation, the greater will be the covalent character of the ionic bond. This is also true. Okay, higher the charge, higher will be the covalent character. Hence, we will say that this C statement is also correct. This one is saying lesser, hence D statement is incorrect. Okay, let us have a look over here. So, the correct statements are A and we have C. Okay, so what is this Fajan's rule talking actually? Okay, so basically this Fajan's rule gives us the extent of polarization. Okay, and let us have the third postulate. This statement says that for cations of the same size and charge, over here we have talked about different sizes and different charge. But what if there is the same size and there is the same charge? Then we will go on and say that the one with an electronic configuration of n-1 dn-ns0, which is typical for transition metals, okay, that will be more polarizing than the one having a noble gas configuration, that is of Ns2 and Np6. This is typically seen in where? Yes, it is typically seen in alkali and alkaline earth metal cations. Okay, so these are the 3 postulates of Fajan's rule which you should remember. Also, you should be clear on what are the terms polarizing power and what is polarizability. Okay, so the correct answer over here becomes option B, which is A and C. These 2 statements are correct. Now friends, let us move on to the next question. The next question we are having is giving us statements. Let us go for the statement 1. It says that the electron displacement in an organic molecule takes place due to the influence of an atom or a substituent group present in a molecule. Okay. Then we have another statement as well, which says that inductive and resonance effects are examples of electron displacement effects. Okay. So, what are we supposed to do? Option A says that statement 1 is correct and statement 2 is incorrect. So, basically we need to see which of these statements is correct and which of the statement is incorrect. Okay. Then we have option B, which says 1 is incorrect, 2 is correct. Option C says both the statements are correct, and last option D says that both are incorrect. So, over here this electron displacement in an organic molecule can take place due to the influence of atom or a substituent group present in a molecule, or it can also take place when there is an attacking reagent. Okay, and this electron displacement can be permanent or it can be temporary. You might be already familiar with this, right? When we are talking about permanent effect of this electron displacement, we will have the inductive and resonance effects. Also, hyperconjugation is an example of permanent electron displacement effects. So, basically, with our analysis, we can say that both the statements are correct. Over here, this statement, first one is the correct one, and then we have the second statement which is also correct. Okay, and for example, we have inductive, hyperconjugation and resonance effect, which are the example of electron displacement effects. Now, these are the permanent effects. What about the temporary effect? Which effect keeps on changing? Such questions can also be framed in your examination and you should know. So, students, mesomeric effect is the effect which keeps on changing, and it keeps on changing with respect to the structure. So, the correct answer over here becomes option C, which says both the statements are correct. Now, let us proceed with the next question. The next question we are having is about this hybridization again. See students, this hybridization topic is very important for your examination point of view. The question is a fill in the blank type of question. It says the number of species in which the hybridization of N atom is sp are dash. We are given with the 4 candidates. Over here we have NO2 plus, then we have NO2 minus, then we have NO3 minus, and then finally we have NO2. Here are the options for you. 1, Option B says 2, option C says 3 and option D says 4. So you need to find out what is the hybridization of all of these things, and then you need to find out how many of them are having sp hybridization. Okay. Over here only one component is having the sp hybridization, which is NO2 plus. The rest are having the hybridization of sp2, as you can see over here. So for this NO2 plus, the structure is like this. N is doubly bonded with 2 oxygen atoms and there is a positive charge. So as you can see, this molecule is linear, right? And the bond angle is equal to 180 degree. Okay. And there is participation of one s and one p orbital. Hence the percentage s character is 50% and percentage p character is also 50%. Okay. So this NO2 plus is the only molecule given to us in the question which is having sp hybridization. The number of molecules showing sp hybridization is 1. Therefore, the correct answer will be option A, which says only one molecule is having sp hybridization. Now friends, let us move on to the next question. The next question we are having is about the chemical equilibrium. Again, a very important topic with respect to your exam. It says which of the following statement is not a characteristic property of chemical equilibrium. Okay. The option A says after reacting, the chemical composition of the reactants and products change with time. Then we have option B, which says catalyst has no effect on the equilibrium constant. And then we have option C, which says forward and backward reactions do not stop even after reaching equilibrium. And last option D says rate of forward and backward reactions happening at equilibrium is the same. Okay. So basically you are provided with some statements about chemical equilibrium. Over here, this statement is very true, which says that catalyst has no effect on equilibrium constant. A catalyst will always be obtained as it is after the reaction, and it will also have no effect on the equilibrium constant. Then the forward and backward reactions do not stop even after reaching equilibrium. Actually, on equilibrium, both the rates are equal, okay, which is said in the last option. Rate of forward and backward reactions happening at equilibrium is the same. Now over here, this first statement is logically incorrect. It says that after reacting, once the reaction is done, then why will be the chemical composition of reactant and product change with time? Okay, that will not happen. Hence option A is the incorrect statement. It is not a characteristic of chemical equilibrium. Over here we can see it is unchanged with time after reacting. Okay, hence the correct answer will be option A for this question. Now friends, let us move on to the next question. The next question we are having is asking us the IUPAC name of this compound. Again, naming as per the IUPAC nomenclature is very important with respect to your examination. Such questions always come in your examination. So the compound given to us is K3FeNO2 thrice and then we have CN3. Okay. Let us have a look on options. We have option A, which says potassium tricyano trinitrito N ferrate, and then we have 2. Option B says potassium trinitro tricyano N ferrate 3. Option C says potassium tricyano trinitro N ferrate 3, and then last option D is potassium tricyano trinitrito N ferrate 4. So before naming it, we must know how this complex actually dissociates. Okay, let us have a look over here. This is the complex provided to us, and this complex dissociates as 3K plus FeNO2 thrice, Cn thrice, and with a charge of 3 minus. Okay, now we have 3 minus. Okay, so the given complex is actually an anion, and hence the name should end with 8. This is the basic step you must know while starting to name such compounds. Then the oxidation state of Fe should be known to us. Let us calculate that. This Fe, we will keep it as X, okay. Then Fe will have plus, then we have 3, okay. And the charge on NO2 is minus 1. Then we again have 3, and here the charge on Cn is minus 1. And this whole thing is equal to minus 3, okay, as per the details present over here. Okay. Now rearranging, you will get that x minus 6 is equal to minus 3, and hence x will be equal to 6 minus 3, which is equal to plus 3. Okay. So this is the oxidation state on iron. Now naming it, the name will be potassium tricyano trinitro N ferrate, and the oxidation number will be 3. Okay. Now since we were talked about some groups, let us talk about those also. NO2 minus is the nitro group, okay, and nitrito was also spoken in the options, right? This nitrito is the ONO group, okay. So the correct answer for this question becomes option C. Potassium tricyano trinitro N ferrate 3 is the name of the given complex.